take away an edge, take away an node. If you take this graph and you take away a node, you get this graph. Now, you don't get this graph or this one, depending on which of these you take away. Right? So, the idea is to think that there could be primitive identity that was contextual. That means that it makes no sense to expect the individuals out of the context of the structure as a whole to carry around their primitive identity with them. So that's what I have in mind for that box there. Primitive identity that's contextual, therefore not implying hexatism, therefore not coming into conflict with physics, where we seem to want to deny that worlds differing only by the permutation of individuals are distinct. So Kaplan, in a famous paper, How to Russell Frege Church, thinks that PII implies hexatism. That's because he thinks that primitive identity must be intrinsic primitive identity, but I say it needn't be. Therefore, failure of PII does not have to imply hexatism. That means it doesn't matter if quantum particles or space-time points violate PII, that you could still think of them as individuals without being committed to worlds differing only by the permutation of them, in conflict with how physicists tend to think about things. In the mathematical case, we definitely have violation of weak discernibility. If we want to say those things are objects, they have to be primitively individuated. Maybe you've got some reason for thinking that there's something about the physical world that means that things can't be primitively individuated. I don't know. That's an open question. Maybe there's something about the difference between abstract and concrete structures that requires that, I don't know, you might have that thought. I suspect that, I think for the mathematical case, you must accept primitive contextual individuation. I don't see why you can't accept it for the physical case as well. If you combine primitive contextual individuation with a logically thin notion of individual, then you can say bosons are individuals. And then there are big questions about the relationship between all this sort of stuff about structuralism and holism. And I know Shamika's made that connection. So here's my conclusion. If weak discernibility is appealed to in support of the claim that quantum particles are individuals, that's structuralist. Whether bosons are weakly discernible depends on whether the language used is sound. There's no reason to deny that relations can individuate, properties can. There's a coherent structuralist idea of primitive identity that does not imply hexatism. Thank you very much. A lot of what I say about structural realism is over to Steve French, but he doesn't agree with about this stuff. I wrote a paper on PII and quantum mechanics with Thomas Bigash. And we have this project at the University of Bristol on foundations of structuralism, and a lot of the results I was talking about are in a joint paper with Oystein Lindberg and Richard Pettigrew. And you can find out about the project from there. And thanks again to Barry and Heather. And finally, I'm sorry because I gave him really very little to go on in terms of replying. So thank you very much.
Thanks, James.
So,
Everything.
So I'm just going to pick up on one argument that James touched on in the middle of his paper, which is the one that I reproduced at the top of the handout. And so the idea behind this argument is that if we think about quantum particles in the singlet state, we'll get a good argument for a view called structuralism. And so the first thing he notices is that the particles in this singlet state share all their observable properties, or they're indiscernible, or something like that. And so given that they share all their properties, or observable properties, they can't be individuated. If we think of them as individuals, they can't be individuated in terms of those observable properties. And so they'd have to be individuated in terms of something like a Higgsity or a primitiveness or something like that, which by definition is supposed to be an unobservable feature of those particles. And that's supposed to be, violate some good empiricist principles that we shouldn't allow unobservable stuff into our fundamental ontology or something. And so the idea is if we deny that those quantum particles are individuals, or kind of say that they're individuals in this sort of weak sense where they're just nodes in a structure or something, then we sidestep the whole question about how they're supposed to be individuated. That's the argument I'm going to focus on. I should say that I don't know that much about quantum mechanics and the philosophy of quantum mechanics, so I'm going to say very little about the particles in the singlet state, and in particular about premise 1. I hope that discussion of that comes up in Q&A, because of course that premise is relating talk about wave functions, which is the way we usually describe particles in the singlet state, to talk about the properties of those particles, and that link between wave function talk and property talk is, I think, far from trivial. But I don't think I'm really qualified to start questioning James on that front. So I'm going to instead just make one comment about the methodology of that sort of argument, and then say something about the metaphysics. Okay, so the first thing I want to say is that I don't think we've been told nearly enough about what structuralism is supposed to be to evaluate an argument of that form. We get some slogans from James's work. So I wasn't given a paper, so I just had to pull slogans out of some previously published stuff, which I've reproduced on the handout. And these slogans are helpful, but they're not nearly enough. For one thing, they sort of point in different directions. So sometimes we're sort of told that James wants to dispense with intrinsic properties. Other times we're told that he wants to dispense with haexieties or primitive distances or something like that. Other times we're told that he wants to dispense with individuals themselves. Or yet other times, like earlier in the talk, we're told that he wants to primitively, contextually individuate individuals in relational structures. So those theses aren't all the same. You can dispense with intrinsic properties without dispensing with individuals. And so it would be nice to hear a little bit more about exactly what structuralism is trying to get rid of. But the other problem with these slogans is that we're given very little positive to go on. So we're sometimes told that electrons aren't individuals, but we're not really told what electrons are in any positive sense. Or at other times we're told that individuals are to be individuated in terms of their relational structure, and that relational structure is really what part of our fundamental ontology. But we're not really told what relational structures are. Right? Are they kind of complex entities composed of relations? And if so, how are those, what are the principles of combination by which the relations are put together to construct a relational structure? So I think that, well, let me just say that my complaint here isn't the sort of Russell complaint that, you can't have relations without relato. And I'm not saying that the theory that James is offering us is sort of simply too wild to believe, or too radical departure from our pre-theoretic conception of the world, that we should dismiss it entirely. I'm not saying that, because I think I agree with probably a lot of people in this room that we shouldn't expect the fundamental ontology of the world to fit neatly into our pre-theoretic categories. Instead, my complaint is just that we haven't really been given a clearly specified, precise theory, either a metaphysical theory or a physical theory, to assess. I think that much is clear, and I think James would probably agree with what I've just said, but there are three interpretations of what he's up to, on which the lack of a clearly stated theory isn't actually such a problem. So what I want to do is just go through three interpretations of what James might be up to in this sort of argument, and argue that none of them are very attractive, and so the lack of a clearly stated theory, I think, is something of a worry for the project. So the first interpretation is something like this. Look, think of the argument at the top of the handout as being an argument just for the purely negative claim that electrons are not individuals, or that there are no, or that they're supposed to be, that they're not primitive individuals, or something like that. Don't think of it as an argument for any positive claim, right? The positive view about what the world consists in is work for another time. I don't take the argument at the top of the page to have established anything of that sort. That's the first interpretation. But I think if that's James's idea, I think it's important to see that it's not very attractive. To see this, just change track just for a minute, and remember the old kind of debate between Newton and Leibniz about the nature of space. Okay? So Newton had this conception of space, which contained metaphysically repugnant structure, namely velocity through absolute space. And Newton, I think, was perfectly aware that this structure was metaphysically repugnant. He knew that it was undetectable, and he knew that in some sense at least it played no real role in his theory. So question, should he have claimed that there is no such thing as absolute velocity? Well, I think the answer is clearly no, because he had no other empirically adequate and clearly specified physical theory to adopt in its stead. I mean, he knew that there were other theories of the structure of space out there, right? He knew about Leibniz's relationalism. But he had this terrific argument, the bucket argument, right? That purported to show that that picture of space couldn't even account for inertial effects, so it wasn't empirically adequate.